Uh-oh. What's going on there? That ain't good. There's an arc went all the way through somewhere. What's going on, fellas? In this video, I got this ozone generator up to about 7.8 amps on camera and about 10 amps before I turn the camera on. I've never seen such a powerful ozone corona. You can actually see like a ½ inch worth of drag where there's like an ozone film traveling from the outer electrode there. And this thing is just incredible, but I pushed it a little too far, let it get too hot, and we burn a hole right through the quartz tube. But just wanted to post this quick video showing that I have been able to tune this power supply to get an exponential power output. There's an electric transmission down here. Depending on the configuration you have these switches set at, you can alter the frequency band, or the band of frequency that it'll operate in. You can make it wider or lower because the potentiometer can only offer a small spectrum of the available spectrum of bandwidth this thing can crank out. I've got this thing cranking 10 amps into the system here, and I just want to show you the power coming off of this test electrode. This is a dual lined electrode for you guys who haven't seen this yet. And this discoloration is from me cutting the tube, not from the ozonation itself. However, this thing's going to get screaming hot with 10 amps going into it. You have got to see this. This is crazy. Okay, I'm going to turn it on all the way here. That's full power. Now, I had it going at 10 amps earlier. It might take a second. But even 6 amps, it's like insane output. Look at this thing, man. It's like a light bulb. It's very hard to get these things that bright. And in oxygen, it's going to pull even more current. A lot of strange secondary action going on. Oh yeah. This thing is humming, dude. Look at that freaking corona drag on there. Check that out. This thing is just screaming. That is incredible that we're getting that much of a corona film. Same thing down here. I can feel the heat coming off of this thing. That is an extremely powerful unit. Uh-oh. What's going on there? That ain't good. There's an arc went all the way through somewhere. Not cool. We got too hot, guys. That's what happens when you get too hot. It's the first time I've ran it this powerful, but if you get too hot, it can burn through. Yeah, we're done for. It's only about 1.2 amps. So, that'll be interesting to examine. We're gonna have to let this cool down. That's good to see. I got this thing working so well that we are burning up quartz tube. That's what I wanted, to be honest. The last thing I want is a power supply that ain't capable of doing this. We could have turned this thing way down. So they say what you do is find the resonance frequency, and then there's a current limiting potentiometer right here that is never to be set over 80%. I've got it right about 75% there, maybe not. But once you get the resonance set, they say to set the current limiter so that what we just seen doesn't happen. I actually need to turn it all the way off for it to cool down. Sometimes after that happens, if you let it cool off a minute, you can fire it back up. But I would imagine what we've done is burnt a hole in the dielectric somewhere inside the tube. So when this cools down, we'll take a look at it. But I just wanted to show you the ferocious output we were getting. simply by adjusting that little transmission right there, as they called it. It has 4 gears. So I don't know which one is the 4th gear, either all the way down or all the way on. I'm not quite sure. Alright, Juan, so what we've seen right there is one of the unfortunate attributes of research and development. We now know that 10 amps is just a little bit too much for this cell. I don't know if I'll be able to focus in on this, but there is a perfect pinhole burnt directly into this glass. An actual hole. See that? You could stick a wire right through that. That was what we saw there, a little lightning bolt shooting off. Now, when I turned on the camera initially, it was after I hit 10 amps. I got so excited that I hit 10 amps, I thought I'd fire up the camera and show you. But then it made a liar out of me and exploded. It only got to about 7 amps this time, I think. I'll have to double check the footage, but we were above 10 amps. And this thing was glowing like a light bulb. It was really cranking. And as you see here, the electrode's been discolored. And if stainless steel has the same annealing properties as regular steel, we can tell by this straw color that we were in the 400 degree range. So a significant amount of heating was taking place, which definitely would attribute to the failure of this quartz tube. Not exactly sure where that burnout. Oh, there she is. Yeah, look at that. Right on that weld. Ironically, that weld's got some little high points there, and we all know how charge likes to accumulate at a point. So little burrs and spikes, like you see here, we've got a bunch of little burrs. That all needs to be smoothed off. That's causing these high intensity little channels. We'll look at some footage and try and figure that out. I'll show you what I'm talking about, but I'm definitely going to have to sand this. And I have another tube that we can slide in and test. But I'm going to try running this thing at 7 amps. I'm going to put another tube in. So just to be clear, Juan, the main purpose of this testing that we're seeing here is not only to determine the maximum amperage that we can run our actual cell at, but I also need to get a visual perspective on validating the concept that when you're at your highest amperage, you're always producing the hottest corona. I'm just trying to validate that. I want to make sure there's not a scenario where we're not showing high amperage, but yet we're getting less corona than what I had seen at a previous setting. And the reason why that's important is because as we get into building these cells, I won't be able to see the corona for the most part unless we spring for the extra coin on getting an observation window in these things, which I don't know that we need to do all that. I think just having a good ozone meter is going to be better than a sight glass any day of the week, because maybe the hottest corona isn't the most powerful corona, you know it? Maybe somewhat less than the hottest corona, because they say you want that fuzzy corona more than the little streamers. So there it is, just a quick little vid. I just wanted to show you that I'm making progress with dialing in these potentiometers and that electrical resistor transmission. A 4-speed resistor transmission, I guess is what you'd call that. So I'm shutting up. I'm gonna put all this away and get everything set up for the next test. Another very important observation was discovered in this test, and that is that when you do in fact break down the dielectric barrier and burn a hole through the dielectric, the current drops off drastically, like 90%. So that's a good indication that a tube has failed. So for future reference, when we see those readings on the amperage gauges that we put in place, we will know that we have indeed lost a quartz tube. But they're saying the ceramic tube's the way to go. However, I can't validate we'll be able to use this transformer on ceramic tube because the dielectric breakdown of ceramic is far higher than that of quartz, which is one of the reasons they say that you can get higher potency ozone off ceramic tube versus quartz tube. The problem is, Juan, when you go into buying things like ceramic tube, it's not a high commodity where people are buying a lot of them. So we would be forced to buy a couple thousand of them at a low cost for each unit, but we'd still have to buy like a $3,000 crate of ceramic tube, even if we just needed one. We're probably not just going to be able to find a place to sell just one or two for very cheap, or even 100 for that matter. They usually have a minimum order of 1,000 on most items that you order. Not in every case though. For instance, I buy these from a supplier, and he sells me these 30 at a time. These are some silicon carbide nozzles that I sell. I've got some really neat ones here. This is called recrystallized silicon carbide. These bad boys are like jewelry. They sparkle. Very neat, amazing little burner nozzles right here. These can run at 1600 Celsius continuously for a year straight even. Nothing will happen to it. So there are situations where you can buy bulk and you're not forced to buy 100, but we may not find someone. Frank's been real good to me. I've bought from him before, so I've been able to talk him into smaller orders than most places. Most of the places that I got a quote from would not sell me a package this small. They wanted to sell me a freaking shipping container's worth. So we may get into trouble, but we may not. I've got proof right here. But that's the next step. I think it'd be more durable. I do. Because I know for a fact that ceramic has a higher melting point than quartz. I kind of just spouted that off at the mouth, but I'll check it, and if this ends up making the cut and editing, then you'll know I knew what I was talking about. But I'm shutting up. That's all I got for this test. Just wanted to share those findings with you.